Now we're going to talk about how to find the domain of radical functions. So these are functions that have square roots. And the reason that we need to talk about the domain is that there are some numbers that if we plug them into a square root, we'll get something that's undefined. So for example, let's look at h of x equals the square root of x plus 5. And let's evaluate, let's turn on my pen. And let's evaluate h of negative 7. If we plug in negative 7, we'd have the square root of negative 7 plus 5, or the square root of negative 2, which in the real numbers is undefined. So this tells us that negative 2 can't be in our domain. But what else can't be in our domain? The thing is, nothing that makes the radicand, makes the thing under the square root negative, can be in the domain. So what we're going to do, so to write that out, we want to say the radicand, and that's the thing under the square root, must be greater than or equal to 0. So to do that, we're going to set the radicand greater than or equal to 0. We'll solve for x, and that will be our domain. So it's a little different than the rational functions where you're finding what you leave out. Here we're finding what is the domain. So for h of x here, we want to set the radicand, again, the thing under the square root, so we want to set x plus 5 greater than or equal to 0. So we'll subtract 5 from both sides to solve for x. And we'll see for our domain, x must be greater than or equal to negative 5. So our domain, the interval greater than or equal to negative 5 would be negative 5 with a bracket up to infinity. Okay, and let's look at one more. Here we want to look at j of x, which is equal to the square root of 6 minus x. And we want to find the domain. So we're going to set the radicand 6 minus x greater than or equal to 0. Okay. Here we can add x to both sides. We get that 6 must be greater than or equal to x. And another way of saying that is that x must be less than or equal to 6. We can flip it around as long as we see the less than part is pointing toward x, and here the less than part is pointing toward x. So here, if we look at a number line, we want everything 6 and below. So here our domain is from negative infinity up to 6 and including 6.